Good morning, good afternoon, or good evening, depending on when you're watching this video. This is Mr. Ray with our next lesson in grade 10 academic math. What we're doing today, based on the original units, we'd be starting Unit 3 today. So this is Unit 3, Lesson 1, but you can tell by the name of the unit, it's really a continuation of Unit 2. There's just too much content to throw everything into one unit. So I've kind of split it up in this way. But you do have to understand the stuff we've learned in Unit 2 in order to do well in this unit. It's not a standalone unit for sure. Okay, today what we're doing is we're doing something called solving a quadratic equation by factoring. So what does that mean? Well, the word solving, if you remember back to grade 9, we solved linear equations. Basically, that meant find the value of the variable, which is usually x, find the value of x that makes the equation true. So when we're solving quadratic equations, it's the same goal. We're trying to find the value of the variable, which usually is x, but not always, that makes the quadratic equation true. So now, when we did solving linear equations, there's pretty much, well, I think in 99% of the cases there was exactly one answer, and it was our goal to find that one answer. Quadratic equations are a little bit trickier, and we'll get more into that in the next couple of lessons, but there could be 0, 1, or 2 possible values that the variable could have that would make the equation true. So when I say 0, it means basically there's no value of the variable that would make it true. So most of the time there's going to be 2, and then there's a chance it could be 0 or 1. So if I'm just looking at a generic quadratic equation, I've got ax squared plus bx plus c equals d. Now d could be any number, c could be any number, b could be any number, a can be anything, but it can't be 0. Okay, so you basically got your values here. Now, for example, I could have this equation as my example: 3x squared plus 4x plus 15 equals 0, and it's our goal in the next 2 lessons to figure out what value could x have that would make this true. Okay, so with quadratic equations, we actually have 2 techniques. Okay, that we're learning the first technique today, and that's by factoring. Okay, so I'm showing the 2 branches we could take here. The next lesson we do, we'll be looking at this approach. So today, we're looking at solve by factoring. So the thing you guys learned, hopefully have learned, is that just because I give you a quadratic equation doesn't mean you can factor it all the time. So if I gave you one of those equations here that you can't factor, well, this technique is not going to help. So we can only use this in some circumstances, but you still have to know how to do this. So we're starting with this method because in actuality we've already kind of encountered this, and I'll explain that when we do the examples. We've already actually done solving by factoring, even though you may not know that. Okay. Now the other technique that we'll do in the next lesson is we're going to solve this quadratic equation using the quadratic formula. So I'll be teaching you that in the next lesson. Now this technique always works. Okay. Now what happens if you have no answers? If you actually know ahead of time that there's no possible value of x that makes this work, well, the quadratic formula will tell you that, or it will tell you here's the 1 solution, or here's the 2 solutions. So this is like this always works, and the problem is it's a fairly complex formula. So if you can factor it very quickly and solve it that way, that's an advantage for time. But sometimes this works, whereas this always works. Okay, so example, solve by factoring. What we're going to do, I'm not going to try to factor that now, but I'm going to get, say, x minus r, and I'll just throw a 3 here because there's a 3x minus s equals 0. If I was able to factor that into this, then if you remember when we did the x-intercepts, the fact that I have two factors multiplying here and I'm getting 0 must mean that either this is 0 or this is 0. This whole x minus r becomes 0, or 3x minus x equals 0. So in this case, you could see, well, the value, in order for this to be 0, x would have to be equal to r. That would be one solution. And this one would be, if I set that to 0, I'm going to see that x is equal to s over 3. So that's what we're going to be doing today. There's a little bit more to it than that, but basically we take a quadratic equation, and it could be in any form. The example I'm using is standard. That's usually the way we get these questions, but it might come to you already factored, or it might come to you in vertex form. But the goal is to get it into factored form and then set the factors to 0. Okay, so that's what we're going to be looking at today. So now the roots of an equation, we've already been kind of using it. It's basically very similar to the x-intercepts, but this is a more broad term. It just basically means this is the answer, the solution to solving a quadratic equation, the value of the variable that makes the equation true. Okay, it may or may not be an x-intercept, but we'll look at that later. And this is kind of the rationale that we've talked about. If the two factors have a product of 0, then one of the factors must be 0. That's why we, that's why we did this. Since this is 0, then either this is 0 or that's 0. That's kind of our tool that we use. A quadratic equation has a degree 2, which means it's got a squared term, and one unknown, which is the x. What's the value of x? Now, this says some quadratic equations can be solved by factoring. Looking from the other perspective, that means that some cannot be solved by factoring, which we've talked about. So what we're going to do, we're going to set, now we haven't talked about this yet, we kind of glazed over it a bit. In order for us to solve a quadratic equation, we have to have the original, or we have to convert the original so that it has a 0 on one side. Okay, and we'll look at examples where we have to do that. And then what we do is we factor the left side, where the x squared and x are. And then we set each factor to 0 and then solve for each of the unknowns. Okay, and the solutions are also known as the roots. Okay, so let's look at some examples here. And don't forget, we're solving equations, so that means you've got some expression equals some expression. It's got to have an equal sign in the middle. It can't just be looking like that. That's not an equation. X squared plus 9x plus 14, that's an expression. Once you put equal to 0, it becomes an equation, and you can solve it. I cannot solve x squared plus 9x plus 14 because in reality, I could throw anything in for x I wanted to. So there's no solution if it's just an expression. So it has to be an equation. So now, what we'd look at, the first thing is it written in the form we want? In other words, do we have a 0 on one of the two sides? And we do. Okay, so we don't have to do any work. What we do now is we factor the x squared plus 9x plus 14. And if you remember, this is a simple trinomial. You have to remember how to factor. So go back to your notes and remind yourself. So I know this is a simple trinomial. So that tells me if it does factor, it will have an x as the first term in both binomial factors. The other terms here, and don't forget the equal 0. If I'm looking at what those numbers are, those two numbers multiply to 14 and they add to 9. So you could do the table of factors, the different pairs of factors that multiply to 14. But this one's pretty straightforward because it's either 1 or 14 and 2 and 7. Sorry, it adds to 9 here, not 7. 2 and 7 work because they multiply to 14, they add to 9. So positive 2, positive 7. Sorry, positive. Sorry, I was right the first time. No, I wasn't. So they add to 9, and the two numbers are positive 2 and positive 7. And you can check this. If you expand this, you're going to get x squared plus 7x plus 2x. That adds to 9x plus 14. Okay, so now that we've got this arrangement, we got factored on the left side, 0 on the right. Now we can use the fact that since the product of these two things is 0, one of them must be 0. And it could be either one. So now this is the way that I would recommend doing it. Okay, you set each factor to 0. So x plus 2 equals 0, or x plus 7 equals 0, and then we solve for x. So a lot of these you'll just look at and go, well, x has to be negative 2. But you can still use your rules that you use for linear equation solving. You subtract 2 from both sides, and you get x equals negative 2. That's one solution. And this one here, you'd subtract 7 from both sides, you get x equals negative 7. Okay? And then you could kind of go back and say, well, would these work if I plugged in negative 2? So if you plug negative 2 in here, you get 0. And here it doesn't really matter what you get, because if it's 0 times anything, you get 0. Okay, so that we know that works. And we plug negative 7 in here, well, we get negative 5. But here we get a 0. So anything times 0 is still 0. So we know those are right. So what I would recommend, you could put kind of a conclusion here if you wanted to. X equals negative 2 or 7. Sorry, negative 7. That could be the way you write it. Now what you should not write, because it doesn't make sense, is x equals negative 2 and x equals negative 7. Because that means it has to be both, and it obviously can't be two numbers at the same time. This says it could be negative 2 or it could be negative 7. If you put an and there, that's not a logically correct statement. Okay. All right. So let's try this one here. So this is a quadratic equals 0. So that's set up okay. Now it's not a trinomial, so we wouldn't use simple or complex. So I take a look at that and go, well, yeah, Mr. Ray always told us we should try common factor first. And if I do that, I'm going to get a common factor of x. And if I factor that, I get 2x plus 5. Okay. Now that is factored. And if it makes you feel better, I like doing this. Put a bracket around the x, even though it's not a binomial. You don't have to. But that kind of tells you it's this times this equals 0. So either this equals 0 or this equals 0. Okay, now this being 0, you've already got your solution, right? If x was 0, this is 0 times anything is still 0. Now this one here, this is where I'd recommend, do your solving a linear expression. So subtract 5 from both sides. 2x equals negative 5. So x equals negative 2.5 or negative 5 halves. So I'm able to change it to a decimal in this case because negative 2.5 is exactly the same as negative 5 halves. If it was something like 5 thirds, I would leave it as 5 thirds because I can't write 5 thirds as an exact decimal. So these are the two solutions here. Now, I'm kind of running out of room, so I'll bring this up here. Okay, so when we look at this, I'll rewrite it again. Okay, so this is an equation. It's a quadratic equation because I've got an x squared in it. Just one sec. Okay, it's a quadratic equation because it's got an x squared term, but it's not set up the way we want. We want it to look like these other ones did, where it's equal to 0 on one side. So this is not equal to 0, so the first thing we have to do is get all the terms and over to one side so that I have nothing here or a 0. So I'm going to subtract 15 from both sides. And when I subtract 15 from here, I get 0. So now it's set up the right way. Okay, there's no, I think some people might want to factor this and then set the factors to 0. Well, you can't do that because the fact that these two things, the two factors would multiply to get 15 does not imply that one of them has to be 0. In fact, that would not work if one of them was 0. So we always want to have a 0 on this side, otherwise we can't use our technique. So now what we're going to do, we're going to factor this. Now this is going to be two binomials again. Okay, that's going to be a complex trinomial. So I'm not going to do that here. If you need help with this, you can join the math help, but this is something you should know how to do or go back and remember. So when I do factor this, you could either use decomposition or intelligent guess and check. And the factors are 3x minus 5 equals 0. Sorry, 3x minus 5 and 2x plus 3. And we can check that. We've got a 6x squared. We've got a 9x. We have a minus 10x. So a 9x minus 10x is minus x. So that worked. And then a minus 15 from here. So we know this is the factoring is correct. Okay, and now we set each factor to 0 like always. Okay, now don't fall for the old, I've mentioned this on previous lessons. Don't just, I know the trick was before, you just switch the signs of the numbers and that's your answer, right? Well, when you have coefficients for x here, that does not work. So it will always work if you just set the factor to 0 and solve for x. So that's what I'll do. So 3x equals 5 because I add 5 to both sides, and then x equals 5/3. That's one answer. And this would be one case where I should not change it to a decimal because it goes on forever when on your calculator. Don't round it to like, what would that be, 1.6667, right? It's still not exact, so leave it as a fraction, okay? This one here, I'd subtract 3 from both sides and then divide by 2. So that's -3/2. Now in this case, I can, if I convert that to a decimal, I could change it to -1.5. That's totally legit. So this, I would accept either one of these two. I would only accept this, not 1.667. Okay, so these are the two answers, and if you wanted to, you could plug both of them back in here, and you would see that, left side equals right side. Okay, so that's how we solve by factoring. And make sure that you've always got the 0 on the right side before you start factoring. Okay, so got a couple of word problems here. Okay, so this one here, we do have an equation, so that's good news. It's quadratic, so let's read it. The path of a stone thrown into a ravine is modeled by the quadratic (-x squared plus 5x plus 84). X represents the distance in meters traveled horizontally, so to the right in this case, and y represents the height in meters above the surface of the river at the bottom of the ravine. How far does the stone travel horizontally before it hits the water? So that's a lot of information. I would always suggest draw a little sketch. So our sketch will look like this. So here's the cliff over here, and actually I'll make that a little bit lower. So if that's the cliff here, okay, and this, I'm going to call this variable the x. This is the horizontal distance in meters. Okay, and this will be the height in meters, okay, of the stone. And this point here, that's the origin. So that's where the height equals 0 and the horizontal distance equals 0. So we're basically throwing the stone from the top here. Okay, now there's a couple of hints here. I'll mention one now. The fact that it's -x squared, that means that a is negative and it opens down. Okay, so I'm not going to have a parabola that goes like that. That would defy the law of gravity, and it would also not mimic this equation. So it's going to open down. Now, whenever we do a question like this and something is thrown in the air, we can always assume that we throw it up into the air and then it comes down. We don't throw it straight down. So we toss it up in the air and it lands here. Okay, so this, actually that was not h, that was y, but it's really measuring the height. So a lot of times they'll put an h here for the height. Okay, so when I look at this picture, I can, when I think about a parabola, I can think about three important points here. This would be the y-intercept. This would be the x-intercept, or one of them. And the point where it reaches its maximum, that would be the vertex. So anytime we have word problems, and we're trying to figure out something about a situation, it almost always involves one of these three things, either the y-intercept, the vertex, or the x-intercepts. It could have two. So let's go back and maybe gather a bit more information now that we've got a sketch we can look at. So, well, basically this is the equation y equals negative x squared plus 5x plus 84. Okay. Now, there's another clue here for doing the sketch we haven't talked about yet, and that's this number here. The fact that this is in standard form, and the only real interesting thing that standard form ever gives you is the c value, or the constant. That's the y-intercept. Okay, so that's basically, you could think of it this way: if x was 0, this would be 0, this would be 0, and then y would equal 84. So I can look at my diagram and say, well, where's that point? Well, when x is 0, y should be 84. So I can actually say that point there is 84 meters off the ground. Okay, and that kind of implies that, when you throw it up in the air, if they asked us how high the stone goes, you could know that it should be higher than 84 because that's where it started from. Okay, but that's not what this question is asking. It's asking, how far does the stone travel horizontally before it hits the water? So I guess we should make this look more like water. So that's the point that we want to know. We want to know how far did it go from the edge of the ravine or the cliff before it hit the water. So remember, we talked about this. This is an x-intercept. Okay, so what we want to know, so the y value here, which is the height of that point is h equals 0. The height is 0 when it hits the water. So I'm going to go back to my equation. I'm going to write it again. And the fact that it asked, we want to know the height, which is y, when, we want to know the horizontal distance, which is x, when the height is 0. And the height was y. So keep interchanging these values. So according to the equation, this is where y equals 0. So if I'm looking for that point, and I know that point has a y value of 0, I'm going to change the y value to 0. And now we've got a quadratic equation. And I've actually got the 0 on one side. It's, we talked about being on the right side, but it could be on the left side. Okay. Now, here's a little trick. Because I know that my next step would be try to factor this. Okay, but I'm looking at that negative sign and it's making me a little nervous because most of the factoring we did, the x squared term was positive usually. So we can easily fix that. And the way we do it, and we can only do this if it's a 0 here, I'm going to multiply the whole equation by -1. Okay, so that means multiply this by -1, this, and this. So when I do that, 0 times anything is 0. Now what happens to these terms when I multiply by -1 is it just changes the sign to the opposite sign. So this becomes x squared, this becomes -5x, and this becomes -84. And now this looks a lot more appetizing to solve because we're not dealing with a negative x squared term. Okay. Now the other way you could have thought of this is if I just add x squared to both sides, Come over here. If I subtract subtract 5x, it'll get rid of this. I'll have a minus 5x here. Subtract 84, that'll go away. I have a minus 84. So basically you would end up with x squared minus 5x minus 84, and nothing was left over here, so it'd be equal 0. So that's another way of explaining how this works as well. So either move everything, I hate to use that, but basically get rid of everything on this side, so it turns up over here in the opposite sign, or just multiply everything by -1. You get the same result. So now our goal is to factor this. And anytime I ask you to solve by factoring, you can factor, okay? So just because you can't figure it out or it looks hard, if I say solve this by factoring, it means you can factor it, okay? Even though I've said you can't always factor, when I ask you to factor solve by factoring, that implies that you can factor, okay? I'm not going to try to trick you. Okay, so we're going to factor this. Now this is a simple trinomial, so I know I'm going to have two binomials that both start with x, and then when I do my, what are the values of these two numbers? Well, I know they multiply to -84, and I know they add to -5. Okay, so this one I'm actually going to do the t-chart here because it's a little more complicated with the bigger number here and also the fact that they're negative. Okay, so I'm going to go through all the combinations. So 1 and 84, 2 and 42, 3 and that would be 28, 4 and 21. So quite a few combinations. 5 doesn't work. 6 works. That would be 6 and 14. 7, that also works. 7 and 12. 8 doesn't work. 9 doesn't work. 10 doesn't work. 11 doesn't work. So that's all the combinations. Now let's think about the signs of these numbers. So when I see they multiply to something negative, one of the two numbers must be negative. And then I look at this. When I add them together, I get negative. So that means the bigger number is negative, smaller number is positive. So, if I wrote it this way with the smaller number on the left, bigger number on the right, I could just go down this right column and change all these to negative. Because in order for it to be negative, it has to be this combination. So now I just add these up. So I get -83, -40, -25. You can see I'm getting lower, and I'm looking for -5, -17, -8, -5. So it was the last combination. 7 and -12, so +7 and -12. Okay, so we factor that, and now we're going to solve. So when you solve by factoring, it's always factor first and then solve. You don't forget about the solving part. A lot of students just see factoring and they just leave the answer like that. Now the fact that you've got a 0 there, that means that either x plus 7 equals 0 or x minus 12 equals 0. So that would mean x is -7. That's one answer, one value of x that works, and another one would be x equals 12. Okay, so when I go back to my picture, okay, I know when I factor this I get two answers, but I'm saying, well, there's only one answer here. It only hits the water once. So what does this mean? So this looks like it's, it looks like x equals 12 is the right answer, but what's this -7? What that is this is just solving for the parabola, for the quadratic. It's not thinking about any application of it. It's just the quadratic. So in reality, if I'm just looking at the quadratic, this quadratic, comes all the way down there and it keeps going here. So if I'm solving for that quadratic, I'm going to get two answers. This one over here, -7, and this one here, x equals 12. Okay, now we already know that, well, what does x equal -7 mean? That means the rock actually went backwards and hit the bottom here, but this never really happened. Okay, so what we do is this only happens when we're doing applications, because we can rule out answers that don't make sense. So when I see this answer here, you can just put a big cross through it and say invalid. Another more mathematical word is extraneous, but I'm happy with a big cross. That tells me you considered that as an answer, but you're not going to use it for some reason. Okay, so you don't have to do that over here, but it has to be somewhere. So if you didn't do this part here, I would expect you to put a cross through here and say invalid. That's what most people do. And now we can answer the question. So the question, how far does the stone travel horizontally before it hits the water? Let's make this totally official. The stone travels 12, and now you have to look at the units and you can see that X and Y are measured in meters. So 12 meters before it hits the water. Sorry, I should say horizontally. Okay. So I can't stress how important it is to do that sketch. Okay. Because once you start looking at it, you start interpreting the information. If you just go blindly with this, you're just grasping for straws. And you're just, I see this a lot in grade 10. Students just throw it in a formula and hope it works without really thinking it through. But if you can see, what is the situation and how does it relate to this equation and what am I looking for on the picture, that'll tell you, I want to find where y equals 0 for this equation, and then you go, well, I guess I'm solving it, find the value that makes it true, and then you use your technique from there. Okay, shouldn't be just blindly throwing numbers in the equation without understanding why you're doing that. Okay, this is academic math, which means you're thinking your way through it, not just applying formulas without thinking. Okay, so one more question here, another application. This time they didn't give us a formula or an equation. They said a rectangle has dimensions 3x minus 1 and x plus 1. Its area is 84 centimeters squared. What are the actual numerical dimensions? Okay, so again, here's the value of a diagram, a little picture or sketch. So, and it doesn't have to be a work of art. So I'm just going to draw my rectangle. And I know that, one of the sides is 3x minus 1 and the other one's x plus 1. So it looks like probably the 3x minus 1 is the bigger side. So I'll put the 3x minus 1 there. But in reality, it doesn't really matter. Okay, this is just for thinking your way through it. Now, that's all they gave us, except for the fact that it's area. So area we can put in the inside equals 84 centimeters squared. So this is where we kind of stop and go, well, what's this got to do with a quadratic? So this is where again you have to kind of start thinking about this. Well, this is the area of a rectangle. What do I know about the area of a rectangle? Oh yeah, it's equal to the length times the width. Okay, and all of a sudden I've got an equation where I didn't really have an equation, but it has to do with what information did they give us? They gave us the area. This is the key to building your equation. Okay, the area of a rectangle. Okay, and now that we've got that, we can start filling things in because we actually do know the area. It's 84. Now we don't put the units into equations. We'll add the units back in once we solve it or whatever we're doing. Now the length and the width, that's totally arbitrary. Which one goes first? It doesn't really matter. I'll put the 3x minus 1, but it doesn't have to be that way. And then they multiply with x plus 1. You definitely have to have brackets there. Okay. Okay, now here's where some people will make a critical mistake. And they'll say, oh, it's already factored, so I just find where these equal 0. The problem with that is, this is not 0 here. So I cannot say that, one of these must be 0, because if one of these is 0, then that would have to be 0. So, that definitely will not work. So unfortunately, what we have to do here, we actually have to we have to change this back to standard form. So we have to expand this. Now that's going to be 3x squared, and then I'm going to have a 3x there and a minus x there, so that's plus 2x. And here I'm going to have a minus 1. So now I can actually do something with the 84. I'm going to subtract it from both sides, whereas if I just subtract it from here, I can do that, but I can't use these factors at all. Okay, so I'm going to subtract 84 from both sides, so I get 0 equals 3x squared plus 2x. Now when I subtract 84 from this, I get minus 85. Okay. Now this is where, now if you're factoring something like this, I don't want to see all your factoring work inside the solution here. What you would do is you would do your factoring work on a sidebar or separate piece of paper. I'm not really going to mark you on how you did the factoring. I just assume you know how to do it. You'll get, if this was a 4-mark question, 1 mark would be for the correct factoring. I'm not going to really do all the work here, but if you did, you could use one of the 2 methods, either decomposition or intelligent guess and check. And whatever method you come up with, the answer is 3x plus 17 and x minus 5. Okay, so I'm going to put those back into here. So now that I've factored the whole thing with 0 on the other side. Okay, so it's 3x plus 17, x minus 5. And now I can set these factors to 0 because one of these must be 0 for this other side to be 0. So I'm going to show you a little shortcut here. So this one is pretty straightforward. The solution for this is x equals 5. Now this one here, this is, you don't have to do the whole solving 3x equals negative 17 and so on. What you could do is sort of what the shortcut was before, but with an extra step. So if you consider that the number should be negative 17, but we have to divide by 3. So it's the opposite sign of this number divided by that. That's how you can use the shortcut. So negative 17 over 3 is the other solution. Okay, now I've got 2 answers again, which I've told you we get most of the time with solving quadratic equations. And just like last time where I ruled out one of the answers, I'm going to check to see if these answers make sense. So let's look at the 5 first. If I plugged 5 into both of these, the length and the width, I get a 6 and 14. So that's a possible answer. But negative 17 thirds, that's about negative 5. That's like negative 5 and 2/3, right? If I plug negative 5 and 2/3 in here, I'm going to get a negative length or width. And same thing here, I'm going to get negative values for the dimensions. That can't happen. Anytime you measure something, it has to be a positive measurement. Okay, so again, I'm going to rule out that solution. I'm going to say it's invalid. Now, be careful, because so far every time we see a negative answer, we just throw it out. That's not always the case. Sometimes negative answers do work. In this case, if it's just throwing something, it's always the negative answer won't work. But sometimes a negative answer will work, depending on what these expressions are. So you have to try it out. Just don't assume, oh, it's negative, so it's wrong. Okay. In this case, it is negative, but it's wrong because we tried it out and it doesn't work. Okay. So we know that the only answer is x equals 5. Okay. So I'll say if x equals 5. Now the units for that, they didn't tell us length and width or centimeters, but they told us the area is centimeters squared. So that tells you, in order to get an area of centimeters squared, that means the length and width must be centimeters. So x is 5 centimeters. Now, they didn't ask us to solve for x. They said, what are its actual numerical dimensions? So in other words, what's the length and what's the width? So we have to go back and plug, just like we did when we tested it, the dimensions would be, so if I plug a 5 in here, I get 6, and it's going to be centimeters. Sorry, 6 centimeters. And if I plug a 5 here, I get 15 minus 1, which is 14 centimeters. And you can test your answer out here. 6 times 14 gives us an area of 84 centimeters squared. Okay, now I could also put, and the area is 84 centimeters squared. Don't have to put that. Okay, that's giving a very, very complete answer right there. Okay. Okay, so there's two examples. We are going to do a separate, at the very end of the quadratics, we'll be looking at lots of word problems, and these would be two of the typical word problems. So I want to give you a flavor for, flavor for working with word problems before we actually get to that. Okay, so hopefully, if you look back of the goal of this lesson, it was to know how to solve quadratic equations by factoring. Again, you can't always factor, so this doesn't always work. Tomorrow, the next lesson, we will be looking at solving equations by using the quadratic formula. Okay, but you're still going to have to know how to do both methods. You can't just say, well, I know this method, so I'm not going to learn the other method. You will be tested. There'll be some questions in your assignments that say solve this by factoring and solve this by quadratic formula, and then there'll be some that just you can use whichever method you want. So that'll be up to you, but you still have to be able to do both methods. Okay, so there's some questions here in the textbook, page 279. I urge you to try them out. Make sure you're able to do this, and hopefully that helps. If you still have questions, please join me on my office hours for some extra math help. Okay, thanks very much. Have a good day.